Hello everyone, welcome to the Gaming Ocean, and today we are going to finally be building our computers. We're going to take three different parts I'm about to teach you and put them all together to form the massive computer which you saw over here, which will read off numbers for us. So here we go. We basically start off with an encoder. This is basically our outputs. I'm just making our levers serve as our two outputs. This is only going to count to 3. 0, 1, 2, and 3 are going to be our different numbers for just this short example here. And basically, the encoder puts the numbers in the binary form, just like we did. Our half adder here is our encoder, because the outputs from the half adder go into our lock system over here, which I'm about to show you. So, once you have your encoder, which I'm just having my levers substitute in, you can also have T flip-flops substitute in, which is what I had for this over here. And you can see this system of T flip-flops, they all go in together into this stream of our locks. So now that we have that out of the way, let me start showing you our different system. So, if you watched my advanced lock guide, you would know that we know how to build combo locks, meaning that we have different outputs for the same lever. But for a certain combination, there's only going to be one output on during a given time. So I've programmed a different output for each different possibility, which there's only 4 with 2 levers, because 2 to the power of 2 is 4. And that's our different binary numbers. 0, 0, and if we put 0, 0 together in, I put the binary number at the bottom for you to see, and we'll get 0. This is our output for 0, output for 1, output for 2, output for 3. So basically, if the torch is on, it means that's the number that's on in binary. If I was to change this, it's 0, 1, which translates to 1, and our 1 torch is on. If I was to add this is 1, 1, which translates to 3, and our 3 torch is on, and so on. Our 2 torch turns on. And I'll show you how this works. Basically, you start off, each one starts off the same with redstone stream going into a block. Then out of the block comes a repeater, a block, redstone, block, repeater, block, redstone, and we keep going. Basically, this alternates repeater and redstone because it basically makes it where if you have all this together, it just makes it less laggy, pretty much. If you add repeaters, it adds more delay. So you want to use as much redstone as possible. So as this redstone powers this block, the repeater can catch it, and as the repeater sends power through this block, a piece of redstone can catch it. So basically, if I turn this one on, all this on this back stream turns on. So all these torches along this line turn off. And if we turn this one on, all the torches along this line turn off. Now those send power upwards onto the next part, and this is the part that makes our lock. We already have a NOT gate. So if we want it to be off, we need to make it a double NOT gate by adding another torch. Since this is our 0, 0 line, in order to make this torch turn on, we want both of them to be inverted. That way it's off when both the torches are off. So we add a torch, then you put a block above each one, put redstone on top of the blocks, and for each one you'll have a diagonal block here, and it will catch a stream. If we were to have a third input over here, just to say this one had a torch as well, we would have it kind of like this, and it would go through and it would connect like that. And that's how we're going to program it. For the next one, say we want this to be on. Well, we don't want to invert this anymore, because if we turn this on, that torch will turn off at the bottom. And if we re-inverted it, that means this would turn back on, as you can see. If we flip that, our combination for our 1 line turns off, and the goal is to be the 1 line that turns off. The rest of the lines will be on during this sequence. And you can basically flip through these, and it'll go, and then these streams just go out and connect to torches here. So once you connect all the redstone across these diagonals, it goes out. you'll put redstone here. It'll go up that diagonal to this torch, and redstone for our 3 input. Basically, anywhere you want it to be 1, you do not put a torch back on top. You just leave redstone. Anywhere you want it to be a 0, you put a second torch on top of the first one. We'll build a quick one right over here. This one's just going to count to 1, so we'll start off here. And you're always going to have the redstone to start off with, and repeaters in there. Next, you'll always add a block on top of our torches. Now, this one we want to be 0, 0, so we have to re-invert both ones. And we'll put redstone out here. And I'm just going to build a quick stream for our torch. The next one we want where it will be, if we have 0, 1, it translates to a 1. So our 1 output would have this. Now, this is already turning the torch off, so we don't need to re-invert it, so we just add a piece of redstone. And this one we want to stay off, so since it's already inverted, we add another on top of that. And that's not supposed to happen. There we go. Then this diagonal block basically allows us to connect our ones that spawn on top of the torches to the ones that are below. That's why we have it diagonally. And this will go up. Wrong color. And that powers another torch. And because we have our 1 output on, that's how it's signaled. And you basically use this where it will alternate in lines. So this is the beginning of our decoder. It's called decoder basically because it decodes what the encoder puts in into individual numbers, individual outputs for each one. Now, here's the second part of our decoder. Pretend each of these levers represents a line coming from these. Only one of these will ever be off at one time. So, say this was if we had programmed 0, 1 into it, this line would be off. Now, because this line's off, it allows these torches that were attached to the line to turn on. And now that they're on, they can go down to this stream, and this stream goes into NOT gates, and those NOT gates power the rest. So you basically set this up where if you ever have a 1 programmed in binary in there, it will come out as this certain output. And this output will usually be transferred into our decoders. I just built this one as a basic example. So you put not a torch where you want it to stay on, and say this line was off now. You had a 1, 0 programmed in. Well, this line would be off, and that means we have a different torches on with different outputs. And now the next line's on, they're different torches. And this basically just goes through different torches. It takes them from a top line, and anything that you want to have these bottom lines turn on, whenever this turns off, you put a torch. And then from that bottom line, it will get transferred down until it hits a NOT gate. And that NOT gate will usually go into our display, which I'm going to get into now. So this is pretty simple. Well, I'll go ahead and go over what we have so far. Basically, considering our lock, we have to build, this one was 5, so I had to build 5 torches on the bottom. Then we have each torch go up. Then each torch that we want all these to be off because this is our 0 input. And all these go into 1. And once it goes from this, if this were off, which I'm just gonna kind of simulate right now, it would go here and allow each of these torches to turn on, meaning each one can send a signal down here. I'm just gonna program this. This is our 18 number. 18's programmed at the front. You can see 1, 8 so far, and 18 is here. So this is the one line that's off out of all these, meaning it's allowing all these torches to turn on and send their signal down the stream. It sends it very faintly and catches here and allows the 8 to be displayed. And that's what we're going to be doing next, is showing you how to make the display. Basically, the display is there are multiple ways and dimensions to build it. I like the one where they're just each line is 3 across. Now, if you look at any digital clock, this is basically how it's set up. These are different. These are all the different numbers, and they can be changed to make like this, this, and this would be a 7. Just both the ones on the right would be a 1. All of them being on would make an 8, like this one. And it's 7 by 11, 7 at the bottom, 11 high, and carved out like that. Now, as you can see, there are 3 lines that go horizontally, and then 4 lines that go vertically up and down. And I'm going to show you how to build each one for the piston. Basically, for the piston, you want to do this. You have to have a torch. This torch goes and powers this piston and this piston. Then if you put a block on top of it, it also transfers up the block out to this piston and powers this one. So this makes our line of 3. Flipping this turns off that torch, turning off power to all those. And this basically sends out and pushes it. I prefer the piston just because they seem more defined to me. This is usually kind of that I use. And for our horizontal lines, the ones that only go right to left, you build where you have redstone stream on top of the blocks. Then on each block is a redstone torch. Each redstone torch powers a different piston. If I was to break that one, just this one piston turn off. So you have to have all of them. Flipping this depowers each one. So that's basically how we have it built. We go ahead and we build our display. This is our horizontal line. As you can see, it's the 3 block with the redstone torches and powers each piston. And this is our vertical line, which is, it has this torch, it's powering this piston, and the block above it's powering that piston. And you have to separate each of these into a line, separated by 1 block. And each of these different lines powers a different piece of this. And overall there are 7 different pieces, so 7 lines that you have to use. That is what we have over here with my much larger computer. Each one transfers into one of these 7 lines. The number that gets transferred down goes into each of these and powers it. Now because it's 8, these go into NOT gates and turn all of them off. So all of them are on. If we were to hit a button, and this is going to be a little laggy, that 8 would turn into a 9. And as you can see, these 2 stop getting power because the number 19 from down there is powering it. And then these 2 turn off. The bottom one right here is now contracted, and this one is now contracted. And the rest are, as you can see, extended, giving us our 9. So this is a way to turn that what's down here into a display that we can see. And it powers each individual one. Now, the idea for our lantern one, which is more useful for nighttime things, stuff like that, is pretty much the same. You're going to have different kind of streams that power each of the lanterns, and each one will, in the end, be powered by NOT gates that are each separated by a block. And I'll show you how to do the lantern ones. Going horizontally, right to left, the lanterns are the exact same as the pistons. Basically, torches across, and then lanterns getting powered. Just like the pistons, if you flip this, the lanterns turn off, on, and so forth. There's only one minor change to the lanterns from the piston ones in this case. As you can see, this torch only powers the one in front of it. It does not power downwards just like how pistons do. And it doesn't power upwards without the block. First of all, you have to add the redstone torch underneath on a block, and it'll power this one. And adding a block over it allows redstone to transfer from this torch up to the block, and then from the block onto that. So, turning this lever turns these lanterns on and off. And since they're in lines of 3, we can have stuff like this. I'm going to figure out how to program 7. You just find the line for, you want the top one to be on. So this is our top line. And now it's changed these top rows, so that one's now allowed. And we want both the ones on the right, meaning this line, this line, and this line turn off. If you come out here, it's displaying a 7. Again, I prefer the piston one because it seems more defined to me in the daylight. At nighttime, I'm sure this one is more defined or in dark rooms. So now let's put each of these together. So we have an encoder, which can be just about any input, ranging from levers all the way to T flip-flops and so on. This goes into a lock, and we're going to have one lock for every different output. Since there are 5 here, 2 to the power 5 is 32, there are 32 different locks that I had to build for this. Each one, only one's ever going to be turned off at a time. For this one, this is our 19 line. So once we have this set up, the one line that's off will go over here and allow torches to turn on. Our 19 line here allows these torches to turn on. Once these torches turn on, they travel down this stream, and once you reach the end of the stream, they end up in knock gates here, which allow them to send the stream or stop the stream that's going to these different pistons and lanterns if you decided to build it that way on our line. And this just basically allows you to have numbers displayed for the different ones you have. This is pretty much how all numbers are set up on computers. Different characters have different numbers. There are 32 different bits for every letter on your keyboard because there are 26, so there has to be a 5-digit range. And if you wanted to say an A, your computer really reads it as 00000. If you wanted to put a B, 00001. But it puts those numbers through the decoder, which turns that into an actual number, one single output that you can read, and that single output is shown on your keyboard as a character. And basically that's how these work. That's how I built the half adder one over here, which basically takes the encoder of the half hour adder and puts it into here. I really suggest you build a computer even if it's only a 2-block wide one with 4 inputs, because this really teaches you about binary. I never understood binary until I built computers. This is where it really started to make sense for me. So I really suggest each of you take your time to build a computer, which goes into here, sends streams down, and create this. And just build one successfully, and I guarantee binary will seem a lot easier to you. As I said before, people on our server built a line that was 256. So they built one that had, if I'm saying this correctly, I believe it's 8 different T flip-flops. Then, as the numbers go through, they go into 256 different locks that they built by hand. Well, they used World Edit after a little bit, and then a little bit of it by hand. Each one had a different number that it displayed on this, and then each one sent down the line into a 3-digit one. This one's only 2 digits because it only counts to 31, because it's only 5 digits across. And as you can see, that's just how this works. I'm going to find one just to add one real fast. And this makes it 27. As you can see, this basically just displays plenty of numbers for any player to use. So, this has been Computer Basics with TheGamingOcean. Next time we're actually going to get into less of the decoding and displays and more of the encoding, basically how to add and subtract numbers from this, and how to add specific numbers. It'll be a little bit of a challenge for you guys, so make sure you get the basics of computers before you check out my advanced computers guide that will be coming out soon.